Hello, in this video we're going to look at finding the average value of a function. So the first thing I want to do is look at the word average and remind ourselves what this actually means, and I think this will help you remember the formula for the average value of a function. So if you remember, the way we find the average is if we've got a data set, say we've got 3, 7, 9, 2, and 5. There's our data set, and we want to find the average value. What we do is we add up all the values, we sum all the values, sum of x, and divide by how many there are. So we add all the values, 3 plus 7 plus 9 plus 2 plus 5, and divide by how many there are. So there are 5 values, so we get 19, 21, we get 26 on 5, which equals 5.2 for the decimal, for the people who prefer decimal. 5.2. Okay, well that's the average value of a discrete data set. How do you find the average value of a function? So if that's the average, how do we find the average value of a function? If you have some f of x, what you do is, now integrating is very similar to adding. They have some things in common. The operation of adding is kind of analogous to integrating over an interval. It's kind of like adding and timesing kind of go with integration, and minusing and dividing kind of go with derivatives. This isn't some formal maths thing. This is just what they tend to do. So when you're working out derivatives, if you think of the formula for the definition of a derivative, you're minusing and dividing. When you think of how you learned how to integrate, you have some curve, an xy, you're multiplying to find the area of the rectangles, and you're adding. So integrating is like adding and multiplying. Differentiating is kind of like minusing and dividing. So if we're adding here, that's kind of like integrating. So take your function and integrate over some interval from a to b. So we're summing over some interval to find the average value. And then, just like you divided by 5 over here, you don't divide by the number of samples you have, you divide by the interval. You divide by whatever the integral is. So it's 1 over b minus a. So this formula tells you the average value of a function. This is the formula you need to know. Don't worry too much about that thing there. That's just my rambling. Maybe that helps. Not sure. Okay, so that's the formula from a to b of f of x dx, and a 1 on b minus a up front. So I'll draw you a picture to show what this is kind of finding. The way to think about it is if you have some curve f of x, there's our f of x, and I want to know on average what the value is from here to here, from a to b. Well, this formula can tell me, and all it's saying is if I were to pick a value at random on average, what would it be? So it'll just give us some constant value that's kind of like the average of that function over that interval from here to here. So it's kind of like the average value of that function from here to here. So it's like, oh, there's more positive than negative, so it's going to be more positive. It's the average value, so that's what it means. Fortunately, you just kind of use the formula. Like they don't really test you on your understanding of it. This is just a formula you need to know for the average value. So let's look at an example. So an example might look like this. Find the average value of the function f of x equals 2 sine x from across the interval f of x equals 2 sine x across the interval, and we might have negative pi on 2 to pi. Okay, let's see roughly what we think that average value might be. Let's do a quick sketch in our heads so we know, we can think about this. So from negative pi on 2 to pi, so it's kind of like, that's the interval we're concerned with. So what's the average value of this function across the interval? Well, it's weighted more positively, there's more positive, and it's about, it's 2/3 of the time it's over here, 1/3 of the time it's over there. So I'm going to take a stab. I reckon the average value is going to be like 0.6. Somewhere, I reckon it's going to be about 0.6, looking at that. On average, what y value does it take? Let's use our formula to find out. So the average value, let's call it A, average value is 1 on pi minus negative pi on 2. Watch out for the double minus. From negative pi on 2 to pi, 2 sine x dx. We could do this by hand, but I'm pretty confident that we've covered integrals, so let's see what our CAS can do for us here. So let's put in the interval 1 divided by, and we're going from pi, so we've got pi minus negative pi on 2 times. Now we're going to have to integrate. Shift plus negative pi on 2, that's a decimal point. Whoops, up here, up we go. Oh, it's being glitchy again. Oh no, looks like we're going to have to do it by hand. Let's do it by hand. Pi plus pi on 2 is 3 pi on 2, so that's going to be, it's going to look something like that out the front. Let's reload that while we do it by hand. Is it loading? Yep, doing a bit of research beforehand. And let's integrate sine. Sine integrates to negative cos. So you get negative 2 cos x from pi to negative pi on 2. Come on, CAS. It's being very iffy. Alright, let's keep going. Let's persevere. So you get 2 on 3 pi. And then you get negative 2. Oh, it's loaded several times. No, I don't want you 4 times. Just once. Okay, now it's loading. Here we go. Okay. Negative 2 cos pi minus 2 minus 2 cos negative pi on 2. Okay, so that equals 2 on 3 pi. Cos of pi is negative 1. So that's going to give us 2 plus cos pi on 2 is 0. So that's going to be 4 on 3 pi. So let's see, 4 on 3 pi is approximately, it's about 0.4, 0.5 roughly. So it's pretty close, 0.6. Let's see what the CAS has to say. Okay, take 2. Well, why do I always write it in the worst area? Okay, 1 divided by pi minus pi on 2. Pi minus negative pi on 2 times shift plus negative pi on 2 to pi. And we've got 2 times trig sine x, close the bracket, dx. Okay, let's see how we go. 4 on 3 pi. Excellent. We've got the correct answer there. Let's check if my approximation was close enough. 0.42. Okay, so I was a little off, but you see how to get an average value there. So you can approximate to do a kind of sanity check if you're in the right ballpark sort of thing, and it's really a ballpark figure. And then you can get your exact answer there. So you'll notice the question didn't specify a number of decimal places, so that means it wants exact value. So that's your answer. It wants exact value. Unless it says to 2, 3 decimal places, that's it right there. So that's the formula to remember, and if you have been, thanks for watching.